Flack math! Give me some math and I'll give you some flack. Flack math!
So today we're going to talk about geometric sequences. So arithmetic sequences are when you something is added every time in the sequence. But geometric sequences is when something is either multiplied or divided, or just multiplied, really, because you can add a negative number, so it's kind of like subtraction. But so arithmetic sequences are when you add something get to the next next thing in the sequence, and then geometric sequences are when you multiply by something. So for example, here is a sequence: 3, 6, 12, 24, 48. So just like before, we're looking for a pattern. And this is, you add 3, but then you add 6, and then you add 12. So basically what you're doing is you're multiplying by 2 every time. Okay? So this is a geometric sequence because there is a common ratio. So the common ratio is 2, or the scale factor, same type of thing. But this is 2, or R is what we're going to call it when we define some stuff here. So let's just try an example. And so you need to find the common ratio. Okay, and then next 3 terms. Okay, so here's 6, 3, 3 halves, 3 fourths. And I want to find the next 3 terms. Okay, so find the common ratio. Basically, you just take 2 of these numbers and you divide this one by that one. So 3 divided by 6 equals 1/2, or 0.5. So that's what you're multiplying by every term to get to the next term. Okay, so 6 times 1/2 is 3. 3 times 1/2 is 3 halves. 3 halves times 1/2 is 3 fourths. So then the next one is going to be, okay, 3 fourths times 1/2 is going to be 3 eighths. And then times another 1/2 is going to be 3 sixteenths. And then 3 32nds. So those are the next 3 terms in the sequence. Okay? All right, let's try another example. What if it looks like this? Here's example 1b. -4, 8, -16, 32. Whoa. Okay, so what's our R? Well, R can be found by just dividing any 2 consecutive ones. So 8 divided by -4 is just -2. So you're just multiplying everything by -2. So the next 3 are going to be -64, +128, and then -256. Pretty simple, right? Just like the arithmetic sequences, which felt like we were back in 7th grade math, and that's what it is going to feel like. Now let's get it back to 11th grade math. And find the nth term. Okay, so the nth term, so A of n. Okay, so the nth term is going to be the first term times R, which is our common ratio, to the n-1. So back to our example here, like if I wanted to do remember this 3, 6, 12, 24, yada, yada, yada. So if I wanted to find like the fourth term here, so that's 24 equals the first term times our r, which is 2, to the, let's see, that's the fourth minus 1, so 2 to the third. So that makes sense. So you're basically multiplying by 2, that first number times 2, 1, 2, 3 times. Okay? So this is the formula to find the nth term. So you can plug that in to find the nth term, or we could say, let's say example 2a is find the 10th term of 3, 12, 48, 192, dot, dot, dot. Okay, so it looks like we're multiplying by 4. So that's our r value. So let's plug it into our formula here. A of 10 is going to be A of 1, which is 3 times 4 to the 10 minus 1 is 9. Okay, 4 to the 9th. Ooh, that's a big one. So this is going to be, I'll just skip right to the business here. It's 786,432. So 786,432. So that got really big. That, what's the phrase? That excelled rapidly. What am I thinking of? What is that phrase?
That escalated quickly.
Yeah, escalated quickly. Thank you. All right. I've got, my brain is kind of foggy right now. So, yeah, find the 8th term. So, and then what we also did with arithmetic sequences was finding the nth term given a term and an r. So this all is very familiar with, you know, finding the equation of a line using a 1 point and the slope, 2 points, and it's all kind of like the same thing. And it is very similar to slope because you're trying to find rate of change and things like that. But so if you're finding the nth term, let's see, here's example 3a. I want to find the 5th term of geosequence. Oh, the 5th term of the geosequence is 567. So it doesn't tell us the geometric sequence, but it does say the r value, the common ratio, is 3. So find the 9th term. Find the 9th. Okay. So how do we do that? Well, let's plug it into our values. Well, if I find the 9th term, normally we'd want to put the first term, but we don't know the first term. But remember, we're multiplying every term times 3, okay? So if I put the 5th term, which we know, and then I multiply by 3, how many more times? Well, to get to the 9th term, we have to go 4 more times. So basically, if you're given the 5th term and you want to find the 9th term, then instead of plugging into A1, we're going to go A5, and we're only going to multiply by the common value until we get to the 9th term. So that's 4 more times. So you're going to subtract those values. So let's plug it in. So A of 9 equals A of 5, which is 567, times 3 to the 4th, which is 81. So the 9th term is, do that math, 45,927. Okay. Not too bad. That's a little different than that first formula that I gave you, but it kind of makes sense. You're just multiplying by 3 every time. All right, so this is like you're given 2 points and you have to get it. So this is just find the nth term given any 2 points. Last example. This is what it looks like. So find A1, so the first term of geosequence And we know that the fourth term is 32, and the ninth term is 1024. Okay. So first step, we could figure out our R value. Well, we could plug it into the same thing we did, so we know that A of 9 is going to be A of 4 times R to the 9 minus 4. Okay? So let's see. Let's simplify that. We know A of 9, which is 1024. We know A of 4, which is 32. And R to the 5th. So let's solve for R. So R to the 5th is going to be 1024 divided by 32, which is 32. So take the 5th root of both sides, R equals 2. So if R equals 2, then we can, wait, what did I do? Yeah, R equals 2. So now we want to find A1, right? So let's try this. So we're going to just plug, basically, we're going to just use one of these and plug it into our original formula. So to find the nth term, well, let's say we're finding the fourth term, which we already know, is A1 times R to the N4 minus 1, whatever this one is. So R to the third. So this is 32 equals A1 times 2 to the third, which is just 8. 32 equals A1 times 8. A1 equals 4. So that's the first term in the sequence. All right. So that's just geometric sequences. Pretty simple. There's some graphing questions, but with a graphing calculator, you can skip those if those are in your homework. But that's the gist of geometric sequences. Let's move on to lesson 98. And this, we're going to talk about ellipses. Ellipses, actually, is the how you say a plural of ellipse is ellipses, I think. Maybe I'm thinking of something else. Okay, so this is lesson 98. So you guys know that the equation of a circle they did say ellipses. So ellipses, remember this guy, that symbol there? This is ellipses, I think. I don't know. My brain is foggy. So I'm going to use that excuse probably for the rest of the year. So you guys remember that the equation of a circle is like x squared plus y squared equals r squared. So the radius and then your center, you know, like x minus h squared plus y minus k squared equals r squared. And so your center was here and then your radius is there, but ellipses are a little different. So let's just draw an ellipse. Okay, so ellipses have two different radii. Okay, so, and they're not really called radius, they're called axes. So you've got your major axis and your minor axis. So, like, for example, let me just do this one. Okay, so if I'm going to attempt to draw this ellipse. Not terrible. Okay, so let me identify the different points here. Okay, So we've got this line here. This line right here is called the minor axis. Because it's the shorter one. And then this line right here is called the major axis. All right. And then you've got these points. So the points on the major axis that are on the ellipse, these are called the vertices. Okay, so these are the vertices. Now, these are still called vertex, but these are called the co-vertices. So this is a co-vertex. Here's another co-vertex. So you have vertices and co-vertices, okay? So make sure you know both. So the vertices are on the major axis, the wider ones, or the ones farther from the center. And then the co-vertices are on the minor axis. Now, you could have an ellipse that looks like this, right? So in this case, these would be your vertices. And then these guys would be your co-vertices. This is terrible drawing. Okay, now there's a couple other things you need to know. These are new things, but this guy right here, let me just figure out what that point is exactly. So there's a point right here and a point right here. We're going to call this A. So this is like negative A, 0. And this is A, 0. Those are the vertices. This is our B. Our co-vertices are B. So we're going to say 0, B. And then this one is 0, negative B. All right, and then we've got this new point here. This is like a plural for focus. It's called the foci. I know, it's weird. And that's negative C, 0. And then here's another point, which is C, 0. All right, we're going to talk about the foci a little bit later. But in this case, this is our ellipse. Now it looks pretty. Let me zoom in a little bit just so you can kind of see it a little better. But bottom line, here is the equation of an ellipse. X squared over A squared plus Y squared over B squared equals 1. Okay? So the C doesn't come into play when you're writing an equation. But there is a curvature here, and there's a measurement of this curvature. So this is called the eccentricity. Eccentricity, basically the measure of its curvature. So it's kind of like the measuring slope and things like that, but this is the measure of its curvature. So how curvature, how curvy is it? Curvature. Okay, so C is basically A squared minus B squared. So it's kind of like this weird, so C squared equals A squared minus B squared. Okay, so in this case, if I were to calculate this, well, A would be 4, B would be 2, so 16 minus 4 is 12, so C would be the square root of 12, or 2 radical 3. Okay, so yeah, so that's what C equals. But the eccentricity, let me just back up here. That's what C equals. The eccentricity equals, and I don't think, yeah, there is a letter for it, which is E. Sorry, my notes are a little weird. It's just C over A. Okay, so whatever your C value is, whatever your foci is, divided by your major vertex or your major axis right there. So and it's really just half of that. So it's kind of like a major radius and a minor radius, okay? So again, I've given you a lot of letters. Let's do some real life examples. We're gonna try, so basically, if I need to write an equation. So look at this graph here. So it looks like it goes up to 2 and it goes down to 2, and this goes over to 4 and down and left to 4. So my equation for this, I'm going to write it in blue, is just x squared over your a is 4. So it's just 4 squared plus y squared over your b is 2. So it's just 2 squared, and it always equals 1. Oops, you can't really see that one. Okay, so this is x squared over 16 plus y squared over 4 equals 1. That's the equation of that line. And if I want to find c, then c would just be square root of 12. So remember, it's just a squared minus b squared, right? So you got 16 minus 12, so square root of 12, so c equals 2 radical 3. Okay, so your e value would be c over a, so 2 radical 3 over 4. So it's just radical 3 over 2. You probably can't see that, can you? E equals radical 3 over 2. All right, now if it asks for that, you can do that. But really, it's probably just going to ask for the equation. So it's x squared over 16 plus y squared over 4 equals 1. All right, so the other part in your homework that you're going to be asked to find, or just going to be asked to do, is just graph an ellipse, okay? So I'm going to give you a problem, and we're going to try to graph this sucker. Example 2. I want to graph 25x squared plus 9y squared equals 225. Well, first of all, this does not look like an equation of an ellipse. Remember, it's supposed to be x squared over something plus y squared over something equals 1. Well, let's try to get it in standard form, ellipse standard form. So first of all, this needs to be 1. So what I'm going to do is I'm just going to divide everything by 225. Okay, so that is just this. So x squared, when you do 25x squared over 225, you get, how many times is 25 going to 225? 9 times. And then when you divide 9y squared by 225, you get 25. Well, that looks weird, doesn't it? All equals 1. So now we're in standard form. So remember, your a, this is a squared, right? That equals 9, so that means a equals 3. So this is my b squared. B squared is 25, so that means b equals 5. All right, so let's graph this. That was bad. Okay, so a is 3, so that's where a is. There. Okay, so a is 3, blah, blah. It's technically not A because A is the major vertex, right? Or the major axis. 1, 2, 3, 4, 5. 1, 2, 3. Yep, did that wrong. Okay, so if I were to draw this terribly, that's what it looks like. So now, if I wanted to find C and find E, well, how do you find C? Let's see, it's the square root of A squared minus B squared, okay? So now this cannot be A, this is B, because remember, A is your major axis and B is your minor axis. So we have to switch those around, which is fine. It makes sense because you can't subtract, you can't end up with a negative number anyway. So this is 25 minus 9. Oops, what am I doing? Sorry. Okay, so this is 25 minus 9. So this is the square root of 16, which is 4. So C equals 4. All right, and what was A? A was 5. So E is going to be, remember, C over A. So E is just 4/5. So we've got a 4/5 curvature, whatever that means. But that's the deal. Let's see if it gets any tougher after this. Yeah, so just to review, let's do, and obviously you can move centers, right? So just like a circle, the center is going to be whatever is being subtracted from x before you square it, comma, whatever is being subtracted from y before you square it, okay? So look at this. So here is, let's do a standard form of the equation of an ellipse. X minus h squared over a squared plus y minus k squared over b squared equals 1. Okay? So let's just do one more example and then we'll be good. We're going to just graph an ellipse that's not in standard form and it's not in the center. Okay? So let's try that real quick here. Coming down to another graphing page here. Where are you? Okay, I'm going to graph this. Okay, first step, put it in standard form. So I want to divide everything by 576, right? So then I get x minus 2, parentheses squared, all over 64, plus y minus 5, parentheses squared, all over 9 equals 1. Okay, so this is my A and this is my B. So A squared equals 64, so that means my A equals 8. So B squared equals 9, so that means my B equals 3. And my center, where's my center? You guys know where my center is? Gave you a hint, it's somewhere in the first quadrant. Where's the center of my ellipse? Did I not explain that good enough? So remember, your center is whatever you're subtracting from x, comma, whatever you're subtracting from y. So 2 comma 5 is your center. Center is 2 comma 5. I'm going to get rid of that because I need the room. So 2, 5 is right here. This is your center. All right. And your major axis is 8. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. So your vertex is going to be basically whatever your center x value is plus your a value. And same thing on this side. All right, and then it goes up 3, down 3. So this is what my ellipse looks like. Not bad. I just kind of went for it there. So graph the following equation. Find the center, the vertices, the co-vertices, and the foci. Okay, so how do you figure out the foci again? Well, that's c equals square root of a squared minus b squared. Well, we already know a squared and b squared, so that's 64 minus 9. So that's just 55, square root of 55, right? And there's no perfect square in there, so c equals the square root of 55. And then if I wanted to find the eccentricity, it would just be c over a, which is square root of 55 over 8. That's it.